Okay, so we're going to do a mortgage question here, which is has us practice a couple different elements of a mortgage. So we have Johnny McDonald is applying to his local bank for a mortgage. He wants to purchase a house that costs $450,000, and he has a 15% down payment. And the bank is quoting an APR of 6.5%. Excuse me, we know right off the bat that this is an APR with semi-annual compounding, and we know that because that's how banks quote mortgages in Canada. And this thing is going to have a 30-year amortization, which means that he's going to be paying this thing for 30 years. And the payments is a little different, is semi-monthly. And let's note that semi-monthly means twice per month. So 2 payments a month. Okay, so what are the payments going to be? Well, right off the bat, we can see we've got a problem. Here we have a mismatch in the frequencies. The compound frequency of the interest rate doesn't match the payment frequency. And remember, this is the anchor. So we need to calculate an interest rate that is semi-monthly. So let's do that first. So the first step in that process is to calculate what the EAR is going to be. So that's 1 plus 6.5% divided by 2 to the power 2 minus 1. So that is equal to 6.60562%. And note that the M in this calculation is 2 because it's semi-annual compounding. Now I'm going to decompose this rate here into a period rate, and I need a semi-monthly rate. So to do so, I'm going to take 1 plus the EAR, so 6.60562% to the power 1 over 24 minus 1. And it's 24 because if I have this occurring twice per month, I've got 12 months times 2 is 24. So the M in this question is 24. So that's going to come out to be 0.26688%. And now I'm going to use this rate to solve the question. So the question actually asks, what is the payment going to look like? So I'm going to use the calculator inputs here. So we've got a PV equal to, well, we have a mortgage, we have a house worth $450,000. We're putting down 15%. So we're actually requiring a mortgage of $382,000. Okay, we've got an IY that we just calculated of 0.26688, and the N on this mortgage is going to be 30 years times 24 semi-monthly periods. So that's going to be 720. Then I compute my payment, and that's 1196.40, and that's per semi-monthly period. So twice a month, you're going to pay this amount here. Okay. So that solves that question here. So what are the payments? Now we're going to look at the payments and decompose them into 2 parts. So what portion of this 126 payment is interest and what is principal? So to calculate that, we need the beginning balance of the loan at time 126, which means that we need to find the present value at time 125. Now let's note at time is equal to 125, we have 720 minus 125, we've got 595 payments remaining. So that is effectively our N, okay? So we're going to be looking for what the present value is of the loan at time 125. So the interest rate's still the same, 26688. Our N is what we just solved for here, 595. Our payment is what we solved for in question in part A of this question. So 1196.40. Compute PV. So the value of the loan at this point in time is $356,400. 489.19. That's the amount that you still owe at time 125. Okay, so now we're going to use this information to decompose the payment, which is 1196.40 into the two parts. So we've got 1196.40. So we're going to look at the interest portion first. So the interest portion is going to be equal to the beginning balance, 356,489.19, times our interest rate, 0.26688%. So that's equal to 951.40. So that is the amount of interest that constitutes this payment here. The principal portion is going to be the remaining part. So that's going to be equal to 1196.40 less 951.40, which is equal to 245. Okay, and of course those two added together are equal to the total payment amount. Okay, the last part of this question says, if after 20 years of paying his mortgage, Johnny decides to pay off in one lump sum, i.e. a balloon payment, how much is that payment? Well, that balloon payment is going to be equivalent to the amount that we still owe. Okay, so the present value of the loan at year 20. Okay, so year 20 is going to be equal to, let's do this, 20 times 24, which is equal to 480. Okay, and we would need to figure out what that is equal to. Well, at this point in time, at time is equal to 480, we have 720 minus 480, that's equal to 240. That's the number of payments remaining, and that will be our N. So we have, again, where interest rate stays the same, so 2.6688. Our N is 240 in this question. Our payment is the same. And we're going to solve for the present value of the loan at 480 because that's going to tell us what we have to pay off the entire loan. So the present value of the loan at 480 is going to be 211,829.54. So we have to write a pretty big check in order to pay off the loan in full after 20 years. Okay, so this question's pretty good because it gets us to practice different pieces of a mortgage question. First, calculating the mortgage payment based on an APR that we needed to convert, and then using this information to then decompose a payment into the interest and principal portion, and then finally to evaluate how much you would have to pay off the loan, retire the loan effectively.